This is waiting for me, which is really weird, I'd say. Yeah, it's going. Alrighty. Alrighty. Just a second. Alrighty. I think we are absolutely ready to get started. Well, I just need a bit of water and we will be going. So, are you ready? Hello! It's me again, back in my cave live on YouTube. I said I was not going to stream ever again, but then again, I also didn't expect many things to happen. I didn't expect to come back home. But here I am, and we are gonna have some fun, aren't we? You kidding me? Are you kidding me? All right. Let us continue without the camera for a bit. Not 2 minutes in and the camera is messed up. But maybe just probably it was on for like half an hour and now it is not on. I will try one more trick of unplugging it and plugging it back in. Hopefully it doesn't mess up the stream. But here we go. I'll just keep it off for the first few minutes. And we'll try again. Or maybe I should try it right now. Alrighty. Here we go. And yeah, we're in. Alright, let's have some water. So yeah, this stream was a request of someone. I mean, not the stream, but someone requested a tutorial about C bindings and memflow stuff. Let me just, is it this one? Yes, I'd say this is the thing. C. Yes, exactly. So we are right here. We have this guy, which is Martin Lutk. Tutorial how to using C binding would be super cool because I don't know anything about Rust. So this is it. This is the tutorial about using C bindings and how to get the most out of it. How to learn memflow and use memflow and know the C binding stuff. Well, I'd say watch memflow applied. It's in Rust, which is probably something you wouldn't understand. You look at it, you have some idea of what is happening, but probably don't know exactly how it works and probably wouldn't be able to rewrite it. But the core concepts are there. This is the second episode of memflow applied. And the concept is create an inventory, create a connector, create a kernel, find process info, create the process, find the module, scan memory, and find the match and override it. That's the basic essence of it. And what we're gonna have here is, well, we're gonna go ahead and do just that and see. Well, actually, I made it already. And this is it. This is the whole code of the program using the C bindings, how to set them up. I'll first show you, and that is this memflow cmake example. Here's the cmake lists file. Just copy it in your project. Change git tag to point to development branch, which is change it to point to development branch if you're working with C++ projects, because we messed up the bindings and they currently don't work on the main branch we currently have. And yeah, there is a lot of things happening. And now let me just trigger everyone from the thing. At everyone streaming now. You want to send it to 80+ people? That's the thing, it's an opt-out channel. Just mute the channel if you're not interested in YouTube stuff. Send now. Alright. So what do we have here? We have the C code, the C implementation of the same thing. And to build, what you have to do is cmake build, change directory to build directory and run the make file. And it's gonna clone magically the memflow, build the static library needed for the C bindings. And it's going to give you time to have a sip of some water, or so I say it's water. The most potent alcohol is the most innocent looking. No, I'm not saying I have alcohol. Well, you will know in half an hour. So, it's compiling. The camera is still working, which is an achievement. Yes, it's still working. It's definitely one of them. And now, what we have, we can run the example, and it says match found and success. And basically what we found here was this. We have this program, flag binary, which has a string. There is nothing here. And the whole point of it is that we find the string and we replace it with a different value, and the change persists even after closing the program. And that's basically the thing we wrote in the memflow applied series. And this is the C code. Now, you will see a few go-tos, and that's an alarm to many people on, oh my god, what is this madman doing? Don't worry, there are more of them. But this is actually a really nice way to clean up, used all throughout the Linux kernel. Go-tos is a tool that makes sense if you use it correctly. But basically, if you compare it with code, first of all, what we do, inventory and connector. We create inventory, we create connector, and I was supposed to actually check if inventory was created successfully, but whatever. Then we check if connector was created. If not, just clean it up. then create the kernel right here. I was supposed to check kernel, but I did not. Basically, if not kernel, go to cleanup kernel. No, cleanup connector. And that's right here. Cleanup connector. If connector, I forgot. What is it? You know what? Doesn't matter, because kernel will always succeed. Now the question is, how does one find the function names for every single thing? Let me just check if it compiles. Yes, it still compiles. How do you find the function name? What is like an inventory create connector? What is it? Well, it's really simple. We've got people in the chat. Window jiggles when you drag it. Yes. This is quality Linux thing, which is like in addition to camera mostly working, another good thing is that the windows jiggle. I like that. But yeah, back to the topic. If you want to find a function, I wouldn't consult the memflow FFI documentation, because it's very much, let's just say, bare. The way to do it is finding the function in memflow, especially memflow Win32. Memflow Win32. You find a function like kernel. In the kernel structure, you want to have process info. What you just do is you see the kernel right here. Just type in kernel underscore process underscore info, and I think I use that right here. Kernel underscore process underscore info. Basically the same functions persist, I just add the class at the start. That's basically the policy, that like to keep it consistent with most of memflow. And basically what we are gonna do is drop into the build directory rust source memflow. Where is it? Memflow FFI, and the header file. And the header file, for instance, create inventory. Let's say find inventory functions. We find inventory and we have all these functions, and it creates an inventory. Just consult the header and the Rust documentation. The code you may not understand, the examples you may not understand, but the whole idea is that the core idea of memflow is still there and works the same way on C headers. All right, so what are we gonna do in this Rust Wiki, always in the second monitor? Exactly, Kiwi, exactly. That's the way to do it. But yeah, what are we gonna do in this episode, this stream? We are going to make C++ bindings, because as cool as C bindings are, let's just say it needs a lot of cleanup after every single thing. For instance, even you create virtual memory. You don't create the virtual memory object. You just get the reference to it, to the virtual memory object. You get the pointer to it, and you need to free it. You want to access the base address of the module. You get the trait reference, and you need to free it, which is somewhere. Did I miss it? I'm pretty sure. Yeah, I did not miss it. So like you have to free this, and it's rather, let's just say, uncomfortable to write in. It's very verbose and it's very error prone. So let's just fix that by wrapping every single class that needs to be freed into some kind of wrapper which automatically calls the destructor. So we're gonna create we're gonna start with creating a basic, like, generic way of doing it, and because it's the same thing across every single class you look at in the memflow header, actually right here, every single class, every single type dev, it has some create function and it has the free function, and we just want to automatically free it. So we're gonna create a structure which just binds the destructor to the particular class, and we're just gonna do it bind destro, and we're gonna use some C++11 templates, and it's just gonna be some particular type bind it to a destructor function. And if you look at the destructor function, like vert free, it returns nothing. It takes the type, and that's it. That's all it does. And we're just gonna do exactly the same thing. It's a function called, it's this kind of function, takes a t pointer, and that's all. And we just need to name it like this, as simple as that. And we just do that. The structure itself is gonna hold the inner pointer that we allocate every time. And we create a constructor, which constructor for the t structure, kind of. Inner2, and it's gonna initialize. Here we go. And the destructor is gonna do, all it's gonna do is, if we have inner, we just return, we just free it using the free function. And we need to check for null pointer because the code in the Rust always assumes it's not null. That's really, really important, I'd say. And it's all fine. We can create something like, we can wrap right now the connector inventory. Oops. We can wrap it using, let's call it C connector inventory equals bind destructor, and that will be connector inventory, and we try inventory free. We do that, and that's pretty much it. We need to replace this with C connector inventory. We remove inventory free. We don't clean up it anymore. We return 0 right here. And you see it doesn't really work. Why not? Let's see. Expected a semicolon. We expect a semicolon and cannot convert C connector inventory to connector inventory pointer. Well, we're just gonna add typecast, or we can just operator, typecast operator, which returns the t pointer. and it just returns. Here we go. And now it works. And if we run, it crashes. Why is that? Well, it's actually, as you can see, it prints inventory some weird value, which is why is it printing this value? If you look back up, whenever it was printing something, inventory is a really small pointer. Turns out what happens here is we pass through the connector to the printf function, and it destructs it right there because it kind of copies the reference. And there are a few ways to go about it. One would be delete the clone thing, which is, I don't know, kind of, well, it would make it more rusty because that means you can only have one reference. And you know what? It's kind of awesome. IMO, although, yeah, let's do that. We might want to use shared pointer later on, but for now let's just delete the copy constructor, which is single reference. I don't know which way to go, but let's say this equals delete. And if we go about it, we make, and it fails because it automatically deletes the move constructor, which is other, and we just implement it. And other.inner equals null. And it still fails because, well, that's our issue right here. What we just do, access the inner element, and now it's all gonna work like magic. Literally magic. Alrighty, so we solved the inventory. We made it wrapped into a magic destructor type. Now let's do the same with the clonable physical memory. And it's basically C clonable physical memory, and that would be and right here we're gonna do it's some free method, right? Free, one of them, connector free, yes, connector free. And right here we create this thing, and it's gonna be C clonable physical memory object. We do that. We're gonna remove obj because that's not what we do in Rust. Clone inner and make. Still works. Run. Segmentation fault. Why? Well, if you look into, for instance, a kernel builder, when you build the kernel right here, this requires memflow win32 FFI, memflow win32, kernel build. What it does, this function will take ownership of the input memory object. It will take ownership of it. So what we need to do is we need to somehow invalidate the reference. And we're gonna do that by creating an invalidate function. We're just gonna do con.invalidate. And this function right here, inline invalidate, all it's gonna do, save the inner value. Oops. It's gonna reset the inner value to null and return the return value. We do that, run it, and success, it works just fine. Alrighty, now we have the connector out of the way. Kernel, why not do ckernel? Now this is the interesting thing, which is, well, right now kernel has a particular function which is kernel build. So we probably want to have like the build function associated with the kernel, you know, you get what I mean. So what we're gonna do, instead of using, we're gonna create a class which is struct ckernel, and it's gonna just inherit bind the structure kernel free, and it's gonna have a constructor. A constructor of the default one is going to be ckernel it's gonna be kernel, that's a lot of kernels, I gotta say. And it's just gonna call bind destructor kernel. Is it gonna work? Yes, it still works. And we're just gonna do, well, ckernel kernel equals, here we go, it didn't work. Right here we have this, oh, we invalidate right here, kernel.invalidate. We don't need cleanup kernel anymore. Cleanup kernel, just return 0. Again. Use of deleted function. All right, here we go. We still got the reminder to use the inner value. And here we go. Example, success, everything still works. And now we have even one less thing. But now let's just say we want to add the build thing. What we're gonna do this time around, we're gonna use ckernel, and we're just gonna pass the connector right here. And how we're gonna do, we're gonna create a constructor, ckernel, it's gonna be clonable physical memory, and we're gonna move it over mem, and it's just gonna do kernel build mem.invalidate. Hold on. I'll be back in a sec. Alrighty, me back. So what do we have here? Let's see. Will this work? We're gonna have this equals. It doesn't. We're gonna have something. I have absolutely no idea what is going on. All right. All right, this inner, let's just do this. Still doesn't work. I have no clue. No function to call to bind the structure. All right. Can we just do this? Hold on. Alrighty. Isn't this in constructor, no matching function, bind the structure? Yes. Oh, we need to call it like this. We need to call the bind the structure. If we pass a null right here, will this fix? Still doesn't fix. Like we just do. I have. Welcome to C++. Dashi, hello. Hello. Welcome to the stream. Yeah, that's a bit of an issue with my streams. What we're trying to do is wrap the C bindings into really nice to use C++ bindings by just defining these types, which automatically call the free method once it goes out of scope. And that's all. And that's the first step of it. That's what it was. And now we're trying to build in the custom constructor for the kernel, which calls the kernel build method. But it doesn't really like it because, well, I'm trying to move the physical memory, but it doesn't like it. Let's just say that. Does not have any field. Bind. All right, bind this structure. Yes. Let's just see. And cargo watch, that's actually really cool, I gotta say. That's something I remember half a year ago trying to do manually, and it was horrible, but now cargo watch is dope. Thanks for letting me know of that. Cannot bind R value. Yes. All right. It actually doesn't like moving because, well, let's just say C++ is gay. Here we go, success. We made it really, really cool. We just call ckernel with connector and it works magically. You know what? We just need to move this over to its own line. you know what we can do? Process with kernel. We have kernel process info. We're just gonna do that. For process info, we're gonna create a new thing. cwin32. Process info equals that. And basically, cwin32 process info. And that will be process info free, I believe. Because that's literally that's the whole idea, is that the function names are rather easy. What if you leave the rval reference? What if you leave the rval reference in the kernel and type in std Yeah, I mean, I thought of std move, but then you end up with having to do std move over here, and that's just, let's just say, more verbose. So that would definitely work, but the goal is to make it very, very, very clean and elegant, so that even like that, to the point where I'm like, you know what, those C++ bindings, I could use them in place of Rust. I wouldn't, but I could. if you were to ask me. And yeah, we have the process info. What are we still? It's still building. Yes, that's really nice. Alrighty. Now let's do process info right here. Process info, and we pass through a const char pointer. And what we do is kernel process info, this inner name. Now, I believe this will work. I believe this will work. Oh wait, oh, not this one. We just do kernel dot process info. Still success. Still successful. Now let's go to the next level of this. You see, it's all fine. Really, really, really cool that we have this. But you will get to see that we have a process with kernel. It's gonna be a function. Is gonna have a function. We're gonna have this a function. We're gonna have this a function. A lot of functions. So that's a thing. And if you look at this function in particular, for instance, process info, it's all it does, it adds the inner argument and appends all the arguments at the end. It's very much like redundant, and all of the functions are gonna be just like that. Why don't we generalize this and make it so that you are able do you use like a macro or something to define it? So we will start with variadic argument, and that will be template type name, three dots args, and this will have args, and we will just pass args. Does it still work? Yes, it still works. Now there is a bit of a kind of issue if we pass in this like multiple arguments 0. Gonna have too many arguments to function. Oh no, the error is all fine. I was concerned for that, but nothing to concern about. Now, basically our goal is to have a function, a macro, define like wrap fn, and if you pass the function name, you pass the start, which will be class, and you pass the function fname, and it creates a call. It creates a function called fname, which calls into class underscore fname with the input arguments. So to make this very generic, we're missing a few things. First of all, we need the return type to be generic, depending on this particular function's return type. And basically, it doesn't matter if we return the C Win32 process info or a pointer to Win32 process info, because it all gets really nicely converted to the class version. So we basically can use the return type from this function. And how do we do it? Well, we need to include functional. I believe it will be functional. And this is gonna get really tough, I'd say. And this is gonna become std function, I think. Let's just look it up, std function. Right here we have std function, which is gonna have function, the type of the function, and it has this particular thing called return type. And that's what we're gonna do. We're gonna have function return type. And what goes inside? What's the type of the function? Well, DCL type is a really cool thing in C++. It basically has you input something like this, and it will return the type ckernel. But you can input kernel process info, and it's gonna figure out the type of the kernel process info function, and it's just gonna return the type to the type parameter. Not return type, result type. Thank you. Right, result type. Yeah, and it's just gonna output that, and then we can grab the result type from the std function. It still works. Now all we need to do is pop it in the macro. We're just gonna use a multi-line macro. We're gonna rewrite it. Template type name args. We still need a multi-line, and it's gonna be std function DCL type, and we just do class fname. What this does, what two hashes do. One hash converts the thing inside here into a string, and two hashtags concatenate with what comes next. So we have a class name, we concatenate it with underscore, and we concatenate it with fname. And we use spaces to separate the namings to make sure the preprocessor doesn't mess up. And then we just continue as it goes. Result type. And it is gonna be fname, because we're interested in making this particular thing the end of this whole line. Fname. And we're just gonna pass in the args and multi-line, and we're gonna return the same concatenation fname, and we pass in the inner pointer, and we pass the arguments just like that. We still need a multi-line. Here we go. And now what we can do is replace this. We can name it process info too, and replace this with wrap fn kernel process info, and it still works just fine. And if we remove this, just to show you, it still works. Some say like macros is hell, like, and I know myself, macros can become a real big hell if you use them improperly. But I'd say in this particular case, it makes sense because we are literally wrapping a function and calling into the other function, and we can add inline. I'm just gonna make it even better. That inline will basically just completely remove this particular function frame and just leave it with the wrapped function. And yeah, now we're gonna have, we have this kernel process info, and we have, now let's create a process, C132 process. In this case it's okay, but as a project grows it can get really ugly. Yeah, I mean, in like for like regular old projects I would be very wary of using macros, as I had experience with that and it was very horrible. It's a bit of a story that I started using macros to first of all like add some no-ops to change code signature. Doesn't change much, but it's still like maybe mess up the detection vectors. Then I started, macros are really awesome with like you can like, you have one functionality for like loading and the other with saving, the same logic. The only difference is like the single function or like a really tiny snippet of code. Oh yes, let's use macros for that. And I ended up like eventually I ended up chaining macros, macro on macro, and it's like, it's very short, concise, but it expands into like multi-thousand level code, which then is a complete disaster if it crashes in the middle of that macro. Like, you've got like this tiny macro which expands to 1000 lines of code, and the debugger doesn't have a clue where exactly it crashed. And basically it made me abandon the project because it was horrible. So yeah, macros, be very, it's like a nice tool that can be the source of so much evil if you become like me and overuse it. In this case, I'd say it makes sense because it just wraps the single function by doing the same repetitive thing, which is appending the inner thing to the end arguments. And I'd say it makes sense and we can use it here. But if we were to chain macros and macros, become very, very. And Atheros, if I remember correctly, compilers put the inline automatically. Yes, for the most part, they do, especially if you have like optimizations enabled, they do. Although like I still like to add inline because some compilers are not as smart as others. Believe me, MSVC can be very, very unoptimizing in certain cases like these. But yeah, like if you have release build, especially with link time optimization, it can be it can happen automatically, I'd say. All right, what do we have here? So we're gonna have process with kernel, which is gonna be Win32 process is just gonna become C Win32 process. Clean up process, gonna go return 0 here. We probably want to return the error code here, but clean up process, we don't have it. And we're gonna have a struct C Win32 process, and that inherits by destructor, and that will be process free. What did I? Yeah, process free. Process free. And it's gonna have the default constructor. This is something you could also macrofy, and I was thinking of maybe add a macro for the start because it's the same thing over and over again, but it gets messy, especially like it confuses the indentation in the IDEs. If you have a macro right here, if we start a macro which goes till here, we don't end up with needing the opening brackets, but we still need the closing ones, and that would mess up the indentation in the code editors really, really badly. And you got the camera and lighting on point. Thank you very much. It's actually like I've got this mirrory thing which I forgot in the last episode of memflow applied, and I just had like the whole face black on the other side. This time around I was sure not to forget it, but thank you. So we have Win32 process, and it's gonna be the same thing right here, and it's process with kernel, right? Process with kernel. So we're gonna have process with kernel. And we're gonna have the kernel. We're gonna consume the kernel. See kernel, the reference to it, kernel. And we're not gonna consume the process info. So we're just gonna have the reference, the pointer, process info, not the class, because we don't want it to be freed at this point. Info. And we're just gonna call bind destructor. This is interesting. I actually wonder, we're using constructors, but sometimes the thing is gonna be null. I guess it still makes sense because like yeah, I'd say it still makes sense. I was confused whether using constructors makes sense if like kernel build can fail, but the inner pointer is just gonna be null, and you still like need the null checks for them. It's like, but it's not gonna mess anything up. So process with kernel is gonna be kernel invalidate and info. Here we go. We've got a missing thingy at the end. Here we go. Example. Still no crashes. The crash would be mostly like double free or freeing over here and using the freed thing later on. Which is why I rerun it and just using print success. It's very easy to crash, I'd say. All right, we actually don't do it. C132 process. And we can just pass kernel without invalidating, because it will invalidate it later on. Here we go. So now we've got the module info. Here we're gonna have module info, the same wrapafn, process module info. Module info process here we go. I say here we go so many times, I'm pretty sure it's driving you nuts. Apologies for that. And we have Win32 module info, which is gonna be C132 module info. C132 module info. And it's gonna be the same thing. Be good, thank you. Oops. That will be module info free. And we just go in and do alrighty, and is that all? Why are we doing it? Oh, we need the module info trait, and that will be info trait. Let's just, yeah, we can wrap it. We just wrap it using module info trait. Still builds info trait. Here we go, and that's basically, we just need to replace this with OS process module info without obj. That's a long name, I have to say, but that makes us not need cleanup module. We're gonna go back to COS process module info. And this is gonna use multiple wraps in one. Process module info and it's just gonna bind OS process model info object. Module info free. This is the main reason I'm making these bindings, because this particular thing is so long, it's horrible. So this is gonna be really good whenever it gets released, because we need full bindings. I'm just gonna do bindify this whole program instead. I just realized I needed to probably copy out the C version first. Let me do some unwinding. Yes, we have unwinded main C. Here we go, we're back. And that will be back in business. Mod info is gonna call bind destructor, mod info, and now we use multiple wraps. OS process module, and you just type in base, for instance. Just gonna do OS process module. We're gonna base size got too many. Address, parent process, base size. Here we go. Now we've got the thing which is wrapped really nicely, and we're just gonna use mod.base and mod.size. This is gonna work. Oops. Doesn't. Has no member inner. Why not? Hold on. Oh, that's process module free. Here we go. And we just need the function names here, right over here. Success. What we did here is wrap the trait thing very easily, and gotta say, it actually looks good. It actually looks good. But now we've got, I think, we've got just virtual memory. We've got just virtual memory. How are we gonna do virtual memory? Because our trait, the same function name stays in Rust. Like, we don't go to redraw into, because there's like distinctions. I'd say keep it in line with Rust. Keep it in line with Rust is gonna make it very nice. See, virtual memory object. Let's just copy this out. All right, let's work smarter. Win32 module info virtual memory object. Except here, yeah, I absolutely failed this. I absolutely failed this. Let's try like this. Can we do it? Can we do it? And it's gonna be virt free. See virtual memory. A weird redraw. Oh, it underscores it. Wrap. Wrap fn raw. Let's call it wrap fn raw. ASMR. Really? This is live. Yes, this is live. And I'm sorry for ASMR. I mean, not that it's something to be sorry about. People love it, right? I am actually not sure. Do you like it or do you not? I'm not gonna try to pronounce your name because it's obviously not meant to be pronounced by people. But what do you say? They've got wrapfn raw. And yeah, we finally finished. All right, we actually didn't. We actually didn't change this. And we have process virtmem. Process virtmem. The keyboard ASMR is good. It's brown switches. They're really nice. They're not overly clicky, but they're really nice. Try to pronounce it. I want to hear that. 1Q ZX510. Not too bad, I'd say. I mean, unless you say Z in your country, then you're gonna hate me for this. Oh. Yes. Yes. Obviously. It doesn't like it. It absolutely doesn't like it. Maybe we cannot use raw wrapping. Can we wait? What is it? Isn't it in the global namespace? Oh, right, we need to do this. Here we go. Nailed it. Namespace issues. That's my intuition being right. Here we go, success. Success. Why do I ruin it and that's C in C++? What would be another good way of doing it? In a way, I could wrap it in hide the underlying types, but then we kinda cannot access them, which is, I wouldn't like that. C would mean class, but I'm using structs, which is also another thing to note, but like to consider that, I mean, use W, but that's really weird to type. I just type it C. Provide a better suggestion and I may use it. Here we go. I'd say this code so far is kinda finished. Let's change these return types. And we just do this. Here we go. It works. It finds the match. Now for the moment of truth, we have this. Oh, we actually want to wrap right raw function. Right raw function. We wrap it in. It still works if we still got this. There's nothing here, but if we do virt mem virt right raw, here we go. If we run it, we find the match. It says hello world from memflow. It was the longest hello world thing in history of mankind. But if we close it and reopen, it says hello world from memflow. Basically, I didn't lie to you. And yeah, what we did here was we kind of slightly simplified the main function, the whole code. Let me just open up right here. So minus these, which will go into a separate header file. Minus these, which will go to separate header file, which won't be visible, which will be just something that you include into your program, into your source code. The main function is right here. Instead of using these pointers and instead of having these go-to functions, which at the end do the cleanup, we just return, and using C++ these structures, it magically cleans up the code, and it's all really nice. And for instance, Win32 process, we just construct it with kernel and process info, while here we need to use process with kernel, and we need to invalidate the kernel, which is really horrible if you ask me. And another horrible part right here is this code. Just look how long the function name is. But in the C++ version, honestly, right here I almost missed it, but just how small it is. We just have this mod.base, mod.size, boom, done. And hello duck, nice to meet you here in this fine establishment. But yeah, this was pretty much, I'd say, what I set out to do. A bit of macro-y, a bit of templates, a bit of C++. It's something I will probably be continuing later on, finalizing, releasing a header file, which is really nice, functional, and ready to use, ready to plop into your project and be used very easily. So yeah, thank you very much for watching the stream. It was very lovely to have all of you right here. I'd say 5 p.m. Now it's 6 p.m. in the UK, but it's actually 8 p.m. here. Wherever you are, whatever time it is in your country. And thank you for watching, everyone who's watching after it was live. And yeah, I really appreciate you being here, and see you on the next upcoming series of memflow applied. There will also be new things popping up, a little like branching out from memflow. It's gonna be exciting. That's all I can say for you for now. And thank you for watching. Thank you for being here, Dashi. Take care as well, and see you guys in the next video. Bye. Take care as well, and see you guys in the next video. Bye.